Welcome back. This is Module 5, the penultimate module.
In creating virtual and augmented reality. No, I've got it wrong. I was going to try and go for it from memory. So what have we got? Creating virtual and augmented reality applications on the Windows platform.
Well said. Yeah. Well said. So, yeah, we're going to look at user interaction in VR, design issues, you know, and how that paradigm changes.
And all that good stuff.
Yeah. So,
the penultimate one. There's only one left after this. If you've
one
been
left, and that's the store. Yeah. So,
build it and ship it. Right. So, kind of challenges VR. So, you know, we throw around this kind of VR interaction design and that kind of thing. What does that actually mean? What are you trying to deal with? And a lot of the problems kind of come out of how we're trying to build analogs for things that really exist. So, in the video game world, you can be quite creative with controls and how things are presented. So, you know, if you look at a game like Mario, has absolutely no relation at all to how real life actually works or behaves. And you can get away with it because it's on a screen in front of you. But if you were to build a game like that in VR, people would be sick very easily. People would kind of have perception and understanding problems, and you've got to be a lot more sensitive to the users. So, you know, building VR applications is far more about how you're sensitive to user context and what they're seeing and the kind of things that they need to be aware of to feel sort of comfortable and present in that world. And that's kind of the real key. It's very user-centric, whereas, you know, games tend to be very fun-centric. But VR
I suppose there's some quite obvious, like, big challenges, right?
Yeah.
So how do you move around?
Yes. And obviously you've got to find, you either find something that you get away with in that situation. So, you know, if you're running a room scale tracking system, then you move around by moving around. But if you're running mobile VR, you don't have that. So how can you build something that sort of is an analog to that isn't too jarring for the user?
Yeah, I suppose even in room scale, you're still sort of confined by that.
Yeah,
relatively small space.
Movement's a real key problem, one that, you know, nobody's actually solved properly yet. So, you know, when HTC Vive come out and things like that, they're going to have room scale tracking.
Yeah.
Maybe that is the only way it can be done properly. Maybe someone will come up with a good solution before then. But, you know, for now, it's kind of an unsolved enigma.
I suppose another one that occurs to me instantly is that when I look down at my hands, there's nothing there.
Yeah, there's zero.
That makes me feel a bit weird.
Yeah, there's no presence of any kind. So yeah, there's all these sort of issues, and we'll go through them kind of the key ones slide by slide, and we've got kind of some examples and some talking points to go over. So kind of the biggest one is loss of immersion. So that can make you feel really sick, and it's the one that actually breaks your brain a little bit.
So what kind of things can pull a person out of that feeling of immersion?
So, you know, you're immersed when your brain and your senses are getting on with each other. So, you know, your senses are seeing a certain thing presented to you, your brain goes, oh yeah, that's what's happening, and feeds you back the information.
Yeah.
And like we discussed in the earliest lecture, actually, your understanding of the world is considered by your brain to be a key survival instinct. And if something compromises that, it will take immediate action to try and rectify that. The usual action it takes is it makes you sick, or it gives you a headache. And those are the kind of the first two. So, you know, the headache's there to disparage you from doing whatever it is you might be doing. It's kind of a signal to you, it's like, I don't get this, please stop doing this. And making you sick is actually, that's a really fun reason why that happens. Basically, you've got your kind of lobes and cortexes in the back of your brain over which you have no control. So they control your motor skills and the animal part of you that's just running your body and keeping you safe. Is it hippocampus at the back? I don't remember. I'm not a neurosurgeon.
I'm not sure.
But yeah, essentially what happens in this part of your brain is its job is to take the sensory input, make sense of it, kind of shuttle the data around and build this field of view where you perceive the world from. And what happens is if you get disparagement between the things that two of your senses are detecting. So the classic example is you watch the roller coaster VR demo and you feel sick.
Yeah.
And what's actually happening there is you've got one sense that's coming from your inner ear that says, I'm standing, you know, I'm sat at a chair in a room. I can feel from the pressure sensors on my skin that, you know, I've got pressure against my back and my legs. I'm definitely sat down. And then your eyes are telling you that you're hurtling at 100 miles an hour down a hill. Your brain's immediate reaction to that is, I must have been poisoned because I'm seeing things that aren't making any sense. I must have eaten something that's bad, and that's why you feel sick. He goes, right, I'm going to get rid of all the things I've eaten now because that's the only reason that our sort of animal ape brain at the back can make any sense of it, is I must have eaten some bad berries, I've got to get rid of those.
I can recall when I did a kind of roller coaster demo, I was kind of flying downhill quite rapidly. And I recall touching the chair, and that just brought my brain back from that immersion.
It takes the slightest nudge, and it's unbearable, and you've got to get it off. And there's that sort of I think it was a BBC reporter had classically reported that about the Vive headset. They put it on, and they were fine, and they went into a certain thing where one of the sensors broke, and the look direction inverted. So they looked left and they could see to the right, and they had an immediate kind of violently sick reaction to that, because it was your brain going, what in God's name is going on, and then that's it, and you can't actually recover from that without taking the device off.
Yeah, I understand some people are very sensitive as well, aren't they? So it does vary from person to person.
Some people just can't at all, and that kind of number of people dwindles as the technology gets better.
Yeah.
But some people's tolerance to VR is extremely low, and they can't deal with it at all.
Not ideal for the.
No, not great. So yeah, the kind of sort of key points there is that you lose this sense of being in the virtual world, and you can compensate for that with room scale VR controllers and things like that bring more and more data about your actual physical state into the game. But in terms of actually doing that in software, it's something that you sort of have to avoid. So from design consideration point of view, always avoid things that aren't actually happening to the user if you can. So in the previous lecture, we looked at that little bottles game that we did. That was a really good example, because if you go and do that in real life, you're not flying around and moving or in a spaceship or have things hurtling past you. So you've got that lovely kind of sensible world, and your brain perceives that and goes, oh yeah, I know what's going on here, and has a very nice, comfortable experience. If it was, trying to do that while flying down a hill on a minecart and throwing rocks in, or some more bizarre game concept that was more elaborate, probably wouldn't have sat that well with your sensory cortex.
Yeah, and I've seen some techniques being used in games, such as like the blink mode, where it.
Yeah, that's very good. So they've got.
It just sort of moves you forward in big jumps.
Yes.
So you're not sort of accelerating forward.
I think one of the interesting things was there was an Oculus demo I saw that actually had virtual eyelids. So to kind of transition from one part of the demo to the other, these things would come down and it would go dark.
That's interesting.
And then you'd move to the other one and then they'd open again. And actually the users are perfectly fine with that, because that's what you see when you shut your eyes.
Yeah,
anyway.
A bit like a fade, but it's kind of
it's very
ties
natural
in with your body as well.
And they did that very well to demonstrate things like getting into a moving car and things that change in velocity. Because obviously you don't feel velocity, you feel acceleration. So if you suddenly then transition onto a plane that's flying very fast, you wouldn't actually feel the speed of it, so you can kind of get away with it. So it's all about kind of this gradual, this easy change. Kind of brings us nicely onto this. So this is apparently the world's most uncomfortable chair.
It must say it does look very uncomfortable.
Yes, but this is kind of my key point here, and I've kind of written it in caps with exclamation marks, is don't do roller coaster type demos where the player's moving at speed or anything. It doesn't work. It will work one day when we've got the sensors and the technology to do it properly. Currently, anything that involves rapid change in acceleration, and that's really the key. It's that, what is your delta V rather than just your V. Rapid changes in acceleration you can't simulate, because your body can naturally detect them, and we can't simulate that back through visual output. So we've got to think very carefully about when we do move the player, do it very slowly and gradually if you have to, or have a system where you can move around and kind of more.
Yeah, I mean, this could be a key blocker for the whole industry, right?
Well, yeah, because there's so many things that exist that rely on acceleration and movement that you can't do. So yeah, it'll be an interesting thing to figure out how we solve it. I think kind of one of the key ones is to try and look at scenarios where we use room tracking. But interestingly, there's quite a lot of work done in simulation where maybe moving platforms are the key to that, where actually you can tip a user and use the acceleration of gravity. But what happens is if you tip a user on their side in their virtual environment, they'll feel like they're going sideways because they don't realise they've been tipped. So you can actually kind of like hack the gravity vector of the Earth to provide this feeling of movement. And that's what simulation chairs and things like that do. So, there are ways of doing it. Unless you've got the kit to do it, don't do it if you can get away with it, because you'll make people sick. And you'll get your kind of VR heavyweights who can deal with a lot of kind of VR stuff will be all right. Most of the lightweights will be sick immediately and make a mess.
Yeah, and they probably never return, right?
Yeah, and that's it. Then that's the whole technology spectrum's ruined for them, which is kind of a shame.
Yeah, so I mean, there's a whole range of things which cause that kind of discomfort, right?
Yeah, so head movement delay is a big one. So this is one of the things that Oculus have been kind of the pioneers of pushing. You can't have latency because you don't have latency in the real world. Why would you have latency in the virtual one? So you've got to keep it down under that 6 milliseconds. And again, the blue scene with the orange bottles, very simple, very quick to render. Keep it as simple as you can, because you've got to try and hit 30 FPS is good, 60 FPS is ideal, 100 FPS is perfect. So you've got to get it up as high as you possibly can.
Yeah. Anything below 30 FPS,
no go.
Maybe
Yeah.
cut
Cut stuff out the scene if you have to, because it's actually, your game will perform better from having less things that look smoother than having more things that kind of don't allow you to have that immersion, because you just lose the whole point of the. And then you've got individual sensitivity to VR. Some people just get sick. There's nothing you can do about that. Just take it off them and say sorry, it doesn't work for you. And in the future maybe it will.
And I suppose you can build controls into your game or your demo that enable them to maybe take control of some of the things that make them feel sick.
Yeah. So it's
maybe there's a comfort mode in there of some kind.
Something context sensitive, so you're actually listening to user feedback in some way. Yeah, probably a good idea.
Yeah, maybe you could switch, acceleration off when the user's moving or something.
Yeah.
Something along those lines. Okay, so this is a interesting controller we've got up on the screen now.
It's from the 90s when things like that were invented and people spent millions of dollars on technology like that, thinking it was going to be a big deal, and they were wrong, luckily.
It certainly doesn't look very natural to use, and if you are in VR and you can't see outside of your environment, almost impossible to use, I would imagine. It's
kind of it's almost a deeper level than that. It's got to, whatever control interface or mechanism you have, it's got to make some kind of sense in the real world. So you imagine it, whatever it is has got to be real. So
more of a natural style interaction, like
so
we see with the the touch controllers.
Yeah, so that's sort of the really well the tracked position touch controllers are the best, because they have low latency tracking. They look really good. And then kind of moving back to kind of things that have just got gyros in, and you can have some sense of orientation of something you see your user holding and an input of some kind. But that has kind of a reasonable analog between something I do in real life and something I do in the VR world. Okay,
so let's talk through some of the controls we've got in VR and some of the ways we can use our bodies and so on, tracking devices to control. So special gestures, for example.
Yeah, I think the kind of gesture-based control is really interesting, because it's all about, with VR, finding that analog with the real world. That's going to be the thing that the user's going to be most comfortable perceiving, back to the comfort issue.
Yeah.
So if you can bring things like head tilt and eyesight detection and things that are pretty much copies of the way that you do it in the real world, that's really going to help sort of make the user feel more at home, because more of the things that they expect to work in the ways that they expect them to work will do.
And what about eye gaze? I mean, is that tiring? It sounds like it might be tiring to sort of...
I think eye gaze is okay as long as you use it in a way that is natural. So I think if you look at things like foveated rendering, that's a really good example of eye gaze use, because you're actually using that to control something that you'd expect the gaze of the eyes to control. I'm not sure about things like eyesight directed typing.
So you're not making the user do things that are unnatural and may tire their eyes out somehow.
Because generally the movement of your eyes is seldom done. It's just as a sort of stabilizing effect for your vision. Yeah. You don't really use them as an intent device, and I think that when we start to drift into that, there may be issues there. There may not be. I'm not an expert on eye tracking, and maybe that it's absolutely fine, and it's what we've all been waiting for from a control point of view. But I'll remain a skeptic for now.
Yeah, and I guess voice. I mean, I haven't seen too many sort of voice input controls in VR.
I think that's more because voice recognition's not very good at the moment. I think it's actually it's not so much that it's not a natural interface of any kind to use. I think it's just actually, talking about underlying technology, we as computer scientists have not figured out voice control for anything that works properly yet. We're getting there. You've got things like Google Now, Cortana, and Siri. So it's getting up to the point where you can.
Yeah, I suppose it's about learning about how that interaction actually takes place inside VR. In much the same way that all the other things.
I think
do.
Game designers will have a lot to do with pushing that forward. And if you remember kind of the Milo project on Kinect from years ago, that was a kind of a really good first step into that direction. And it'll come. It'll have its time. It's not yet, but it'll be on its way.
Yeah, and then there's controllers.
Yeah.
Of course, you can't see the controller.
Yeah.
So I guess that means it can't be that complicated.
No, I mean,
very, very natural.
I think Oculus hit this on the head, and they really said, if you're going to use a controller while you've got a headset on and you can't see it, use an Xbox controller. It's the best controller in the world.
Yeah.
And I'm not saying that because I'm in a Microsoft building. It's kind of one of the most ergonomic controllers ever invented. It's very comfortable to hold, very easy to use. All the buttons are in natural positions. So pick something well known if you're going to do that. Don't like hack one together yourself and trying to build one that looks like a gun that has buttons all over it for movement or anything else. Just go for something simple that has been designed to be an input controller, or even better,
or the kind of hand-tracked controllers as well that we're seeing. I guess it's quite natural. They're quite natural to use.
Well, that's kind of one step above. You've got this sort of, things like Razer Hydra and the Wii. They are these kind of position tracked items, and that's how you'd expect your hands to react. So, again, I'll keep hammering this point home. The more you can bring the real world into the virtual, rather than trying to simulate it, the better the experience is going to be.
Yeah, and I suppose the things with 3D tracking and bringing your physical representation of your own body into the scene is an interesting idea as well.
Yeah, I mean, things like Kinect are gonna kind of bring that into a new form, and I've not seen anything good done with it yet. But that's not to say that there isn't anything good that can be done with it. I've just not seen it done. And kind of use of 3D cameras for tracking and their implementation will be interesting, and possibly something worth hacking at a VR hack. I don't know why I dropped that hint.
I think there might be one coming up soon.
Yes, I think there is. That kind of thing is actually quite good easy pickings for doing something innovative. So the technology's there. Microsoft democratized time-of-flight 3D cameras. You can find them everywhere. Just pick that up and hack with it, because that could be a really good approach for bringing that kind of more immersive control into the simulation.
Yeah, and then I suppose we've got this whole thing about user interface in general. How does that work now? Because you're now in a 3D volume.
I think
rather than a flat.
There's two kind of key points. Make it very intuitive and very simple. The other one is don't put it on the screen in front of the user. It'll just make them feel sick. So make it real. It's got to be honest. Whether you have a virtual screen that you look at that's in the game that you can move around in 3D, or it's a kind of a floating menu, but it's one that's positionally placed and you kind of gaze up at it and you can see the items on it. So it's got to exist and have 3D depth to it, just as the rest of your world does. So you remember from the VISR demo in the previous module, we had that cursor, but it wasn't just a dot that was drawn on the screen. It was actually moving as if it was on the end of a laser pointer.
Yeah, it really gave you a kind of visual cue, didn't it?
It's just a comfortable thing to look at, and you've got to kind of keep that in mind. Yeah.
Okay, so change in design concept. What does that mean to you?
So the basic concept is that when you walk into a room, you generally kind of mooch around the room a little bit, and you'll settle into wherever it is you're supposed to be sitting or standing, and you'll settle into that environment. And again, talking about analogs with the real world, if you're not doing that in VR, you produce something which will create a kind of very unsettling environment. So, don't create a game like we did earlier where you're knocking bottles off shelves and it's quite fun, and then all of a sudden you get teleported into a spaceship and shot off the Earth at 2,000 miles an hour. That's gonna leave the users feeling kind of very unnerved.
It's almost counter to the kind of when you watch a movie, because sometimes the directors use those kind of really fast, sharp cuts.
Well, there's a really good Fort Minor, the band, produced a YouTube 360 video where they do that, and it jump cuts every few seconds. And actually, when you're creating video content, you look at things that's jump cutting. It creates energy and it makes it look very exciting. In VR, it makes you ill. Yeah. So don't do it. Nice gradual transitions let people settle in where they are. Maybe before you start throwing action and content at them, give them 30 seconds or so to look around the environment and kind of settle themselves in where they are.
Or maybe some kind of gradual or
something that's
without acceleration being applied.
Something just nice and settling, comfortable.
So what's this kind of comfort eye zone? How does that?
So it is actually one of the simplest topics on the thing about design. It's basically when you design for VR, you're rendering this huge sort of it's what's called a 90 centimeter field of view, so you can see loads of stuff, but actually the only thing the user's really concentrating on is about this big in the middle. So you've got this sort of this is where they're looking, and all of this is peripheral. Mirroring your eyes, you've only got a few kind of areas that you can sharply focus on, and so you should keep content in there and don't have stuff that's moving in the periphery that they have to be trying to notice. And
I suppose that's where this idea of sort of foveated rendering comes in as well, right? Because it just sort of sharpens what you're looking at, where your gaze is directed.
And as you do in the real world. So this is foveated rendering is detecting your eye position and the dilution of your irises and that kind of thing, and making sure that that's properly simulated.
Yeah, and this almost looks to me reminiscent of video safe mode, but I need to get that out of my head because it's not that at all. Okay, so let's switch over again, because Alps VR has got a little system built into it which enables you to sort of propel yourself forwards and backwards in the virtual environment.
I think we'd coined it Segway mode. Was the
Segway mode? That's right. Yeah.
So it's this kind of idea that you lean forwards or backwards, and that will make the camera drift forwards and backwards, as if you're on a Segway.
Okay, so let's switch over to the phone, and we'll have a little demo of that.
Let's load it up. I'll make a kind of a small prayer to the demo gods while we get this running.
Okay, let's put this inside the headset again. I can make myself look silly, which is always nice.
And you always will look silly. And you have to just sort of accept that when VR is involved. You're going to look like a bit of an idiot, but that's perfectly fine, because everybody else who tries it is going to look like an idiot as well. So, blue screen's good. That means it's loading. Let's see what happens.
I'll make myself look silly for as short as time as possible.
Well, you could just look silly for fun while it's loading.
There
Made
we
in
go.
Unity?
Splash
Yes,
screen.
it was.
Okay, so I am seeing our usual environment. Now, if I tilt my head forward, and when I get past a certain number of degrees forward, then I propel myself forward. If I tilt myself head back up, at some point in time.
I think you passed it.
Oh, have I gone past it?
It's kind of very
Yeah, there we
sensitive
go.
band.
There we go. It's quite sensitive, yeah. But I'm managing to propel myself backwards. And there are controls in the apps plugin, so you can control the angle.
The angle and the
which you need
speed and
to
the
tilt your head.
direction and that kind of thing. So yeah, it's all pretty well included.
Oops.
Don't drop your phone.
Okay, so that's quite...
Just quite short and sweet. It's just a nice kind of illustration of how you would do something that's very gradual, but also naturally makes sense. You know, that you imagine being in that situation, so your brain can process it very easily.
Yeah, it's a simple solution to a problem.
Just a simple problem, yeah. And there's that that term meat hooking, which is the idea of being dragged along, by the back of your head at 30 miles an hour down a corridor. That's really disorienting
nice.
and doesn't it doesn't sound like a nice thing to happen to you in real life, and why would it in VR? So yeah, moving on to kind of more specialised kit now, I think.
Yeah. So what kind of things do we see? What kind of products can we get?
Yeah. So the nice thing about this is this is all about bring the physical into the virtual where you can, because actually the physical is far better than the virtual. It's got millions of years of evolution behind how it should work.
Yeah.
And so you're starting to see lots of peripheral kit arrive on the marketplace that is providing that interface. Kind of the favourite of mine, which being Razer Hydra, which is just low latency hand signal controllers. They use magnetic tracking, but you get ones like the Oculus Touch ones that use positional tracking from a camera. Or you've got HTC Vive, which is actually very clever in the way that it works, and that's using time of flight in a different way that Kinect does, but it's the same sort of idea that you fire these encoded lasers out of a box, and then you can tell where they are with special receivers.
So it sounds like all of the sort of expected consumer devices that are coming have
some kind of support in one way or another, and that's usually the indicator signal that positional tracking is going to be quite important. So let's think about how we do that.
Yeah.
So this is one of my sort of favourite bits to talk about, and why it's a good hacking topic if you people are thinking of things to hack. Kinect is a fantastic device. It was a real kind of push by Microsoft to find a use for time of flight cameras and computer vision in a way that hadn't been done before in the consumer marketplace. All of that's drifted into allowing things like Windows Hello and proper telemetric sensors, and the Google Tango room sensing thing is based on the same idea, but it was really kind of Kinect that did it first.
Yeah, there's a couple of different elements on it to Kinect, in that you can track people's skeletons and where they're moving in space,
which is very useful for VR.
And also you get the depth information about your environment.
Yeah, so you've got that kind of combination of this really sensitive camera that can be, from a single point in a room, measure depth and distance and stereography and things like that. Yeah. And then on top of that, you've got the kind of real jewel of the API, which is its ability to just extract tracking information, which is, if anybody's ever tried to do that themselves, will know is really difficult.
Yeah.
And just like the Sensors API on the Windows 10 preview, that's all just abstracted away, and you just get
it does make it incredibly easy to get that data back.
And it's a bit noisy, and it's not as great as something that's using tracker markers, but you room scale tracking for $99 or how much it costs to pick up a Kinect now is it's a good deal, a good bargain.
It is
a fun toy.
Yep. And what about products like the Leap Motion?
Yeah. So interestingly,
how does that differ from the Kinect?
Yeah.
That's what.
Leap Motion doesn't work like Kinect does, and a lot of people think it does, but it's actually Leap Motion is a pair of stereo cameras and an infrared emitter. And that's all it does. It's, you know, Kinect actually uses timed laser signals and things like that.
Yeah.
Leap Motion uses stereography, the old-fashioned way to produce a 3D image, and then the computer reads that image.
And isn't it more about tracking sort of your hands?
Yeah. So
something in quite a small volume.
They get a good trade-off from that. So one of the things about that is that's a simple technique and can be executed with very low latency. So Leap Motion's kind of, you can do this in front of it, and it'll keep an eye on your hands for you, and keep tracking even at high speed. The disadvantage of that stereo pair, because they're so close together, is you lose the stereo signal about this far off the desk. So unlike Kinect, you can't put one at the end of a room and have it image the whole room. It's got to be kind of in the near field.
Yeah. And of course, with the Kinect SDK, you can't track hands either, so they're sort of in a slightly different space.
Kinect can track your hands as if you were Zoidberg, so you've got that kind of like, you can do open or shut like that.
Like a crab.
Yeah, and I'd like to see a VR game where some of you just sort of have to... I saw a really great game jam game that was based around the Leap Motion, where you just have to pretend to be a cat and you have to scratch stuff. So yeah, it's, Leap Motion's about hands and high fidelity hand interaction. Kinect's about room scale and position and things like that.
Yeah, and I've seen solutions where Leap Motion is attached to an Oculus, for example. And
they've got an official bracket for that now. They're kind of partners in what they're doing, so it's a nice interesting interaction they've got.
Yeah, that's interesting.
So kind of
we've seen that picture.
Yes, that's particularly uncomfortable, which is why I brought it back for round 2. But yeah, to kind of summarise all of the game design points that we've actually talked about, the key point is find this analog with the real world. Something that the user will understand and be able to relate to. It doesn't have to make perfect sense, and there's a little art in trying to figure out how far can I push it as a designer and get in my I'd really like them to be riding space whales. And obviously there is no analog to that, so how can I find an analog that's sort of similar enough to trick the user mind into it?
And I guess there's a lot of room for creativity in this space.
Creativity, experimentation, go for it, because actually there's nobody in the industry who has the answer, including all the big fellas. They've got a good idea of what's going on, but they don't really know either. So talking about in the beginning how we set up, and we're a new VR company just because we thought there was a particular part that we had the answer about, and there was nothing special about our ideas. We were just some of the first to say it should be done like this. People at Hackathon, people who are kind of watching this course wanting to develop their VR skill, if there's something that doesn't have a defined way of doing it, make one up. Maybe it will become the rendering technique of the future, or the interaction technique of the future.
Yeah.
But always keep comfort in mind, and that's the key.
Yeah. To be honest, after seeing this chair on here, it'd be nice to see something that is actually really a little
bit more representative of what we're trying to build. Yeah. And so this is kind of
a bit like this.
Yeah, this is my kind of key influence slide. It's wrap the user in something that makes sense and something that's comfortable, because it's not just a floating camera. It's not like any other video game that you may have made before. You've actually got a person in the middle of this virtual world that you've created, and it's your job to kind of tender them into understanding it and feeling like they have a place in it. And as long as you keep those things in mind, then you won't run too far off the UX track into something that's going to be making people ill or sick or that way. So treat people right, because people are actually in your simulation.
So that's a really nice sentiment to close out this module, really.
Yeah, it's cool. So we're kind of taking people on this journey from understanding a bit about the VR industry, tips and techniques about how to build their own SDK using existing SDKs, and we've now closed out on game design, and hopefully given you all the tools that you need to build something from scratch that's going to be kind of world bending. And the only thing you're kind of really missing after you've done that is...
Well, it's a submission to the Windows Store, really. And we're going to cover that in the next module. So join us for module 6, and we'll show you how to take that app and submit it to the store.